Welcome everybody. Thanks for tuning in again. Today we're going to talk about how International Atomic Energy Agency safeguards work. A lot of this is going to be about the technical specifics of how these things work. But before starting that, let me tell you a little bit about the agency itself. It was created in the 1950s after President Eisenhower's Atoms for Peace speech. And from the beginning, it had more than one mission. It carries out inspections at nuclear facilities around the world to make sure that they're only being used for peaceful purposes and that the nuclear material is only being used for peaceful purposes. But it also helps promote nuclear energy. It helps countries with the uses both of actual nuclear power, but also of nuclear and radiological technologies for health, agriculture, industry, a wide range of different topics. And it promotes nuclear safety and nuclear security. So it has many different roles. Today we're only going to be talking about the inspections part. The agency is an independent agency. It is affiliated with the UN system, but the head of the agency, the Director General, can only be hired and fired by the Board of Governors of the agency itself, not by the Secretary General of the United Nations or something like that. So it is to some extent independent. But like any international organization, the IAEA is a creature of its member states. If most of the IAEA member states, or even a large chunk of the IAEA member states, don't want the safeguards or inspection system to go in a particular direction, it won't go in that direction. So that the IAEA can really only do what the member states collectively want it to do. And those member states' views are expressed through two main decision-making bodies, the Board of Governors, which is to the IAEA more or less like the Security Council is to the United Nations. It's a relatively small group of states, with some having permanent seats, that make many of the most important decisions. And then there's the General Conference, which is the body of all of the member states. And the vast majority of the countries in the world, whether they have nuclear energy or not, are members of the International Atomic Energy Agency. Not all of them, but the vast majority. Okay, so let's talk a little bit about how IAEA safeguards work. First of all, let's get some expectations clear about what they do and what they don't do. Safeguards are intended to provide what they call timely detection of undeclared diversion or production of nuclear material. So if a country is trying to get some potential nuclear bomb material in secret, safeguards are supposed to notice that. But the IAEA isn't an army. They can't physically prevent a state from doing something that it's prohibited by treaty from doing. All they can do is ring an alarm bell. They can say, this is what's happening, and then the international community has to choose what they're going to do about it. So if states fear the consequences of detection, then the chance that they'd be detected doing something illegal might be enough to deter them from doing it. And one of the main things in Eisenhower's original vision that such inspections were intended to do was to allow international commerce in civilian nuclear technology with some confidence that that civilian nuclear power technology would not be used for nuclear weapons. Despite the name, safeguards are not about providing safety for the facility, and they're not about providing guarding for the facility. So some people who are not very well informed from some countries say, why are you worried about the security of my nuclear facility? It's under IAEA safeguards. All that means is that an inspector might come once a month or something like that. It doesn't mean that there's anybody guarding the facility round the clock. So safeguards doesn't mean safety or guarding. Okay? So I'm going to start off with some somewhat provocative conclusions. A lot of this talk is probably not exactly the way it would be if I were actually working for the International Atomic Energy Agency. There's a lot of things about their system that they're sort of not allowed to say in public. So first of all, one of the somewhat surprising aspects of the system is that the Nuclear Non-Proliferation Treaty has been fairly successful, even though for most of the time that the treaty has been in existence, the inspection system was actually quite weak and had only a modest ability to detect cheating. And so that suggests that there must be something going on behind the success of the treaty that goes beyond just the rational actor solving the collective action problem, because you're not really completely solving the collective action problem if one state, just because another state is a member of the treaty, can't be sure that that other state isn't cheating on its obligations. Now, there are traditional safeguards, the way the IAEA did things for many years, and there are newer safeguards, and I'll talk about both of those kinds of things. The traditional safeguards focused primarily on the declared facility. The state would say, here are my nuclear facilities, and the IAEA would go and inspect at those places. And that approach offered reasonable, though not perfect, performance for declared facilities, for making sure that states didn't remove nuclear material from the facilities that they had told the IAEA about and allowed the IAEA to inspect. They create enough risk of detection that I think for the vast majority of states, diverting from a safeguarded, inspected facility would not be the favored route toward nuclear weapons. The new safeguards approaches, combined with information from national intelligence agencies, offer some chance, a significant chance, but not high confidence of detecting covert nuclear material production. That is the secret site where a country might be making nuclear material. And then turning that nuclear material into a bomb, what's called weaponization, is quite difficult to detect. It can be done in very small facilities, and so you can really only find that if the world gets lucky and there's a lot of cooperation between intelligence agencies and the International Atomic Energy Agency. So just to give you a sense of scale, the IAEA is inspecting more than 1,000 facilities or other locations in almost 180 states. It's about 150,000 tons of nuclear material that's under safeguards. So that's, given the types of nuclear material that it is, it's about 183,000 significant quantities. That is enough nuclear material for 183,000 nuclear bombs, as the IAEA estimates it. That's as of the end of 2012. They have something of the order of 10,000 person days of inspection a year. They spend, in the 2012 budget was almost 147 million euros. That is about the same as the budget of the Vienna Police Department for all nuclear inspections worldwide. It's really a remarkably small figure given the importance to the security of states all over the world of this inspection system. Its safeguards are implemented almost entirely in non-nuclear weapon states under the Nuclear Non-Proliferation Treaty. So the treaty says if you're a state, a non-nuclear weapon state, you have to accept inspections of all your nuclear activities, whereas you don't if you're a nuclear weapon state. However, the nuclear weapon states have all entered into what are called voluntary offer agreements, where they say, well, we'll let the IAEA inspect some of our facilities. And that was in order to reduce the discrimination in the system between the nuclear weapon states and the non-nuclear weapon states. In the United States and the United Kingdom, we have the most far-reaching voluntary offer agreements, excuse me, that say, in essence, any facility in our country that's not of direct military significance, the IAEA can inspect. But since the IAEA has limited resources, and it's, in a certain sense, sort of pointless doing a lot of inspections in states that already have nuclear weapons, why would they divert nuclear material from a civilian facility when they already have plenty of nuclear material for their nuclear weapons programs? The IAEA doesn't actually spend much of its effort on these inspections in nuclear weapon states. There's also a few inspections in the few countries outside the Nuclear Non-Proliferation Treaty that are basically at facilities that some other supplier provided, and that supplier wanted to have inspections at that facility to make sure that facility at least was not used for those states' nuclear weapons programs. But the vast majority of the inspections are in the non-nuclear weapons states. And the NPT member states have repeatedly expressed confidence that IAEA safeguards are working and will verify that states are complying with their obligations. Whether that confidence is well placed is another question. All right, so if you think about how a state might get nuclear bombs in relation to this inspection system, there's really sort of 5 different pathways. One would be, I don't sign up to any of the treaties in the first place, and so I don't have any requirement to accept inspections, and I just build military facilities to produce material for my nuclear weapons. So that's how all 5 of the NPT nuclear weapon states did it. That's how India, Pakistan, and Israel did it. Though in those latter cases, there were some facilities where they had promised other countries will only use them for peaceful purposes that in fact ended up being used for the weapons program. Another option would be to join the Nuclear Non-Proliferation Treaty, to accept the inspections, but then when you wanted to build your nuclear weapon, to kick out the inspectors, pull out of the treaty, and say, okay, I'm shifting these facilities over to military production. That's sort of what North Korea did. It did kick out the inspectors, but it had never had full IAEA inspections from the beginning, and it's one thing people worry Iran might do at some point in the future. Another possibility would be to join the Non-Proliferation Treaty, to accept safeguards, and then divert material from a declared safeguarded facility. So that's really the only one of these pathways that the traditional safeguard system was designed to be able to detect. So then another option would be to join the NPT, accept the safeguards at the declared facilities, but then have a secret facility off to the side somewhere, or maybe more than one secret facility off to the side somewhere where you're really doing your nuclear work. And since the inspectors aren't there, the traditional safeguard system wasn't really helping with that. And that's part of why we have a new and different safeguard system now that includes something called the Additional Protocol, which I'll talk about in a moment. So Iraq did that, established secret facilities before the 1991 Gulf War. North Korea did that with its uranium program. Libya did that. Syria did that. Iran did that initially. Whether it's doing it today or will in the future remains an open question. And then finally, rather than having facilities to produce nuclear material, you might purchase or steal nuclear material from somewhere else. And that's what people worry terrorists might be able to do, because it's unlikely they'd be able to produce their own material, but also between states. For example, it's been reported that China provided a substantial amount of highly enriched uranium to Pakistan, as well as a nuclear weapons design to Pakistan for Pakistan's nuclear weapons program. So there are really only 2 of these paths that are the focus of the IAEA safeguard system. If you're doing things completely outside the system, or you're going to pull out of the NPT and kick out the inspectors, there's nothing that an inspection regime can really do to prevent you from doing that. The things the inspection regime can help with are the paths where you're trying to do it in secret, either at a declared facility or at a secret facility. So let's talk first about traditional safeguards. So this was the safeguard system that was established after the Nuclear Non-Proliferation Treaty had been negotiated. There were a few safeguards in place before the NPT that were basically intended to support nuclear exports, where an exporter would say, I will sell you this reactor, but only if it has inspectors to make sure you're only using it for peaceful purposes. But most of the safeguards came into being when the Nuclear Non-Proliferation Treaty came into being. They use what they call material accountancy. That is, trying to count all of the nuclear material and make sure all of the stuff that was there before is still there and nothing has been diverted. And then also containment and surveillance, which basically means putting a lock or a seal on it, having a camera watching it, so that if it were removed, you might know about it. So some important terms. They're looking for timely detection, and that IAEA has particular standards for how good is timely, based in part on what their estimates of what they call conversion times. That is, how long would it take a state to go from material in a particular form to make that into nuclear weapons. They're looking for significant quantities, which in the IAEA's view is the amount that would likely be needed for a first nuclear weapon, taking into account that the first one is likely to be an inefficient one and that there's likely to be some waste and scrap in the manufacturing process and so on. And they're looking to deter the diversion of those significant quantities by the risk of detection. So the significant quantities are here on this slide. They're 8 kilograms in the case of plutonium or uranium-233. We haven't really talked much about uranium-233. It's another potential bomb material. You can make it from thorium in the same way that you make plutonium from uranium-238. Or in the case of highly enriched uranium, uranium-235 is not quite as reactive as plutonium-239, and so you need a larger amount of material. So the significant quantity there is not 25 kilograms of highly enriched uranium. It's 25 kilograms of the U-235 that's in the highly enriched uranium. So if your highly enriched uranium was only half uranium-235, for example, it was 50% enriched, with the rest uranium-238, then it would take 50 kilograms of highly enriched uranium before it would be before it would have 25 kilograms of uranium-235 in it and be a significant quantity. Now, one issue is the reality is bombs can be made with smaller amounts of material. The Nagasaki bomb, for example, had about 6 kilograms of plutonium rather than the 8 kilograms. That's a significant quantity, and weapons design has improved since then and become more efficient. So they have a timeliness goal for various kinds of material, as I mentioned, and that goal for plutonium, separated plutonium that's not in spent fuel but is separated, ready to go for use in a nuclear weapon, or highly enriched uranium is about a month. Now, unfortunately, that's longer than the IAEA's own estimate of the conversion time, that is the time it would take to make that material into a nuclear bomb. But just in terms of resources, having inspections that were much more timely than that would be difficult. All right, so traditional safeguards are based on the Safeguards Agreement for the NPT, as I said. That's known as Information Circular 153, or INCIRC. There's a huge number of IAEA documents that are referred to as INCIRC with some number. And INCIRC was negotiated at a time when nuclear energy was really expected to grow enormously. It was expected to be the answer to mankind's energy future. And so almost all countries were thinking they're going to have nuclear energy and it's going to be a key element of their national economy. And so the non-nuclear weapon states were concerned to make sure that safeguards wouldn't be so onerous that they would put them at an economic disadvantage, a competitive disadvantage, compared to the nuclear weapon states that didn't have to accept these safeguards. So you will find a lot of the language in INCIRC 153 is about non-interfering, not slowing down states' nuclear energy activities, and so on. And it limits the IAEA to the minimum information it needs to carry out its responsibilities, mostly verification only at a few strategic points within declared facilities. I should say that even this traditional agreement does give the IAEA the right to what are called special inspections at other undeclared places if the IAEA determines that such a special inspection is needed for it to be able to fulfill its responsibilities under its safeguards agreement with the state. The reality is the IAEA carried that out only very, very, very rarely. And the procedures were such that it would be a long time in between when the state knew that you wanted to carry out an inspection at a particular place and when the inspection might actually happen, and therefore potentially the opportunity for covering things up before the inspectors arrived was potentially substantial. The result of this initial safeguards agreement that has such a focus on doing the minimum and not interfering is that there was a culture at the IAEA for some time of really not asking too many questions, of being an accountant and going and saying, okay, you declared you have this much material, I see it's here, here, and here, okay, I've checked the box, I'm going home. Although that's an overgeneralization, there are contrary cases that exist. One that unfortunately has never really been written up very well is the Taiwan case, but I won't really go into that very much more. So the fundamental safeguards measure for traditional safeguards is material accountancy. So you're trying to look for material unaccounted for, or MUF. So you look at, well, how much did the facility have to start with? That's the beginning inventory, plus how much they produced or got from elsewhere, so the additions to that beginning inventory. And then you have what they had at the end, minus any removals, things they might have shipped someplace else, or nuclear material that went to waste or whatever. And in theory, those ought to balance, and the difference between them, if there is a difference, is the material unaccounted for, or the MUF. These days, sometimes MUF is referred to as inventory differences, because among other things, sometimes it can be, rather than the difference being negative, there's too little material, sometimes the difference is positive. There's too much material, there's more than you expect. And that's partly because of measurement uncertainties. Just as if you were running a bakery and baking a ton of bread every month, it would be very difficult to make sure a few pounds of flour here and there didn't go missing. It's the same thing with nuclear material, only obviously it's much more important to make sure that a few kilograms don't go missing. So when you have these uncertainties, these sort of wiggles in the measurement, the question is it just measurement uncertainty, or is there a real loss there? So they look at the standard deviation of the MUF. That is the MUF bigger than you would normally expect at this particular facility? And if the MUF is above some particular threshold, say 3 times the standard deviation, then the IAEA rejects the hypothesis that the real MUF is 0, that is, that there isn't anything missing, and investigates the possibility that some form of diversion has occurred. Now, if you have an item facility where you've just got solid objects, you can just count them and say, okay, the declaration says there are 6, and there's 1, 2, 3, 4, 5, 6. I'm done. So normally there, the MUF should be 0 unless something is missing. So measurements aren't perfect. These are some of the international accounting standards for what the standard deviation should be in percentage. So for a uranium enrichment plant, you can usually get down to something like 0.2%. But for a scrap store or a waste store, you can see the measurement uncertainties are often quite high. All right, so then, in addition to taking these measurements, you want to have containment and surveillance. So those help safeguards by, number one, detecting unusual activity. So if you've got a camera in the area where the nuclear material is, and it's nighttime and there's not supposed to be any workers there, and somebody is coming in and doing something, that tells you something unusual is going on. You probably ought to look into it. It also helps you confirm that nothing has been removed since the last time you inspected. So if you put material in a box and have a seal on the box, and the seal hasn't been broken since the last time you were there, then you usually conclude, I don't have to re-inspect that box. I know that material is there. So they use surveillance cameras, they use tamper-resistant seals, they use tamper-resistant tags to identify a particular item. One issue is experts in the United States and some other countries have concluded that a number of the commercially available tags and seals can actually be defeated if you're clever, and often not very long, using not a whole lot of equipment. So you need to be careful about how much you rely on the tags and seals working all the time. So what happens, for example, when a seal breaks? Seals do break by themselves sometimes. You know, you're moving stuff around, something gets slammed against a wall or whatever, the seal's smashed. So then often you have to go in and re-inspect to make sure that that breakage wasn't associated with somebody actually removing material. So containment and surveillance clearly contributes to the confidence you have in safeguards, but with a count C, you can actually do statistical analysis to see what your confidence is that something hasn't been removed. And clearly containment and surveillance adds to that confidence, but nobody's ever come up with a good mathematical approach to saying, well, how much does it add to that confidence? So you're not measuring everything. Like a bank auditor, you're sort of taking a sample. You examine the records, you take a statistical sample of the material. In a modern automated facility, the IAEA might often rely on the operator's own measuring equipment to take its measurements, and the measurements would be going on continuously. But then you have a real premium on validating the measurements taken by that operator equipment, making sure that operator equipment isn't lying to the inspector. So ultimately, you need to find ways where the inspector makes an independent judgment and not simply believes what the operator says. And the difference between what the operator's measurements say and what the IAEA's measurements say is referred to as MUF-D, the difference of MUF. All right, so if you think about it from a declared facility, there's really 4 ways you might divert. You might divert into the MUF by just removing material, knowing that the records will show that there's missing material and saying, gee, I don't know where that material went. So there's no attempt to falsify the records or what have you. You might divert into the MUF-D. You might say, you might falsify your own records, knowing that the IAEA's measurements will show something different than your records show, and say, gee, I don't know why your measurements show a different number than my measurements show. You might divert with some attempt to tamper with the IAEA's measurements. So if the IAEA was taking a sample of plutonium solution and you knew that there was less plutonium in that solution than there ought to be because you'd removed some, you might try to put a little more into their sample so that it looked like there was more in the solution they were measuring than there actually was. And then the last one is diversion with some plausible disruption of safeguards. You might say, oh, goodness, you know, all the cameras and records got destroyed when we had that fire. And so I don't know where that plutonium went when the fire happened. So the most difficult kinds of places to safeguard are the ones that are handling huge amounts of material in bulk processing processes. And one canonical example is a large reprocessing plant. So a big plant like the one the Japanese have built at Rikasho processes something like 800 metric tons heavy metal, or MTHM, every year of spent nuclear fuel. And since the spent nuclear fuel is about 1% by weight plutonium, that's about 8 tons of plutonium. Now they do usually at a typical plant, they might do one complete closeout where they clean out all the material and all the pipes and everything a year, and with about a 1% uncertainty in those measurements. But so that 1% uncertainty, if you're doing 8 tons of plutonium a year, is 80 kilograms of plutonium. So that's 10 significant quantities. So that's a problem. And particularly if you're only challenging if you've got 3 standard deviations, that would be 240 kilograms of plutonium. Also, you can't meet a 1-month timeliness goal, obviously, if you're only having a closeout once every year. So what the IAEA does is they have comprehensive transparency and containment and surveillance throughout the plant, monitoring the various flows through the plant, having cameras to make sure that you aren't shifting a pipe from one part of a plant to another to siphon off some nuclear material. They actually have laser imaging systems that take a complete 3D image of the inside of the piping and all of that kind of stuff, and then they come do it again to make sure nothing has changed. And they have what's called near real-time accountancy. So they try to take frequent, even if somewhat partial, measurements of the material as it's being processed, rather than only the one closeout measurement once a year. This is just to give you an idea. This is an old reprocessing plant in the United States. You can see there are a lot of pipes. Figuring out where every single pipe is going is a very non-trivial task. All right, so let's talk about some examples of traditional safeguards. Iran is an obvious and topical one. So before their enrichment plant at Natanz was revealed, they had an 18-year centrifuge program that was not declared to the IAEA and was not detected by traditional safeguards. They imported hundreds of kilograms of uranium from China without reporting it to the IAEA, and the IAEA didn't raise any issues or objections for more than a decade. They converted hundreds of kilograms of uranium to metal, and metal is only used for a very few civilian purposes. It's mainly used for making nuclear weapons components. They weren't yet ready to make nuclear weapons components, but they were apparently learning how to work with uranium metal. And there was no reporting of that, no detection of that for years. They conducted real centrifuge tests with uranium hexafluoride, definitely something that had to be under safeguards if they were complying with their agreement. They lied to the IAEA and said they hadn't ever done that. It was detected years later. So this was one of the problems with the way things used to be in safeguards, only looking at the declared activities. However, when other sources, Iranian resistance groups, intelligence agencies of the United States and other countries, informed the IAEA of what was happening, the IAEA has done a very professional job with that information of going in and doing inspections at quite a number of different places and sort of peeling back one layer after another of Iranian lies and false declarations. Hopefully in the future we will not have false declarations anymore, but we definitely did from Iran in the past. So just to give you an idea, let me talk a little bit about safeguards at centrifuge enrichment plants, one of the most proliferation sensitive kinds of facilities. So this is the sort of shape of a cascade for a centrifuge enrichment plant. It's thickest at the middle where the feed goes in. It's a little bit thinner down at the end where the tails, the waste product, come out of the cascade. We talked about enrichment before in class. And then it's very thin out at the product end where the actual enriched material comes out. Now you would think that at a centrifuge plant you'd have continuous monitoring of the feed going in, you'd have continuous monitoring of the tails coming out, you'd have continuous monitoring of the product coming out, maybe you'd have continuous monitoring of the flow and the enrichment level within the cascade, you'd have cameras at key points, and you'd have environmental sampling within the plant to detect highly enriched uranium. I'll talk more about environmental sampling in a moment. What you actually have is significantly less than that. You have, the operator declares when there is feed to be measured, when there's product to be measured, when there's tails to be measured. You don't have continuous measurements of those. You come and measure them when the operator says there's something to measure. And then you have what's called limited frequency unannounced access, or LFUA, within the cascade hall to detect if there are unusual changes, if they've changed the piping around to go from making low enriched uranium to highly enriched uranium or something like that. And then you do have environmental sampling every once in a while to detect if there are highly enriched uranium particles in that building, which there would certainly be if they were enriching highly enriched uranium. At Natanz, you also have more cameras than you have at some other enrichment facilities, partly because at Natanz, since they're still building the facility, they're bringing large objects in and out, and so you have to have more monitoring for the unusual activity than you have at a fully complete enrichment plant. So Iran reports to the IAEA on the feed to the enrichment cascades, the product, the tails. The IAEA has these containment and surveillance measures, including the cameras. They have unannounced inspections. I use unannounced advisedly. The inspectors live in Isfahan, which is some hours' drive from Natanz. So Iran knows a while ahead of time when there's going to be inspection, not a long time ahead of time. Roughly once a month, those unannounced inspections. And those check to make sure they haven't changed the pipes around, and they take swipe samples, these environmental samples, to detect particles of HEU. But the analysis of those samples, as I'll mention in a bit, takes weeks. Then only once a year do they do an actual measurement of all the material on hand. So in late 2008, there was a little bit of a hullabaloo when they found more product and less tails than Iran had declared. But that declaration was Iran's estimate. And the correction of it was done by Iran, not by IAEA inspectors, when Iran actually sat down and measured the material as opposed to having estimated it previously and found that there was more product than they had thought. All right, so obvious questions. Would the IAEA detect it if Iran tried to produce highly enriched uranium at Natanz? I'd say almost certainly yes. On the other hand, it could take weeks to detect, debate it in the IAEA. Iran would attempt to explain it, confirm it, etc. And as Iran adds more and more centrifuges, the time required for them to make enough material for a bomb may slip below the time likely to be required for the IAEA to detect it. So that's one concern. Would the IAEA detect additional low-enriched uranium production at Natanz? There, I think the answer is probably, rather than almost certainly. And LEU might be useful to Iran because if they had a secret stock of low-enriched uranium, then they could use that at a secret facility to produce highly enriched uranium. Whereas if all their low-enriched uranium is under safeguards, then somebody would notice if they took it away from safeguards to use it at a secret facility. So the reality is implementation of something like this all over the world is never perfect. There are, at that time, this is from the 2002 Safeguards Implementation Report. Unfortunately, these safeguards implementation reports are not routinely made public. This one happened to be made public, or at least some of the facts from it, by the Iranian ambassador to the IAEA, making the point that Iran is not the only country that has issues. So they had 34 facilities in 15 states where they would not have been able to detect diversion of a significant quantity with the desired level of confidence. 32 facilities in 15 states where they wouldn't have been able to do that detection fast enough. 6 facilities where the quantity goal hadn't been met for years, and so on. All right, so let's talk a bit about the new safeguards measures. How do we confirm not just that there's no diversion from declared facilities, but that there's no secret undeclared facilities? The key is really integrating information from many sources. Open source information, newspapers, visitors' accounts, that kind of thing. I'll talk about that more. Intelligence information provided by member states. New requirements for declarations of all relevant imports and exports, fuel cycle R&D, and so on. And expanded access to more locations, including for environmental sampling. So this really came in significant part from the discoveries in Iraq after the 1991 Gulf War. Inspectors found that, in fact, Iraq had had a major nuclear weapons program at that time. So there's sort of two different periods. Before 91, US intelligence thought they had a little nuclear weapons program, and it turns out they had a big nuclear weapons program. And then from 91 to 2003, US intelligence made the opposite mistake and thought they had continued their nuclear weapons program when they hadn't. But it was undetected by this fairly large program, was undetected by traditional safeguards and only partly detected, as I had mentioned, by US intelligence. They had huge undeclared facilities. They had some secret activities even at the declared sites. The UN Security Council then imposed an unprecedented inspection regime, essentially an anytime, anywhere inspection regime on Iraq after they were defeated in the 91 war. And that gave the IAEA a chance to test out a lot of new inspection approaches. So then the member states of the IAEA started working together, and they negotiated a two-part approach. One was a set of measures that they thought the IAEA could carry out using the legal authorities it already had under existing safeguards agreements, And then they also initiated a new agreement, what they called a protocol additional to safeguards agreements, or additional protocol, that would give the IAEA new legal authorities. And there, even before the additional protocol, the IAEA, even under the traditional agreements, always had both the right and the obligation, the legal requirement, not only to check that declarations were correct, that is, if they said there are 5 objects in this room, there are 5 objects in that room, but also that they're complete. If they say that's the only room, that is the only room, and there isn't another room over here that has a bunch of nuclear material. But the tools they had available before the additional protocol really weren't adequate to deal with the completeness question. So the additional protocol is a new agreement. States have to sign up to it one by one. There's an effort to make that sort of the standard for safeguards verification around the world. Not yet quite there, but working on it. It includes, it gives the IAEA access to more information. States have to report more about their nuclear programs, including their research and development activities. It gives the IAEA access to more locations, including more opportunities to go to locations other than the ones the state has declared. And it has better procedures for inspections, so you can get the inspector in quicker with less time in between when the state knows you're coming and when the inspector arrives. Most, but not all, states with significant nuclear activities are now participating. 114 states have additional protocols in force out of 179 states that have safeguards agreements. There's some important outliers, Iran being an obvious one. Syria, Egypt, Brazil, and Argentina. The state level concept is, and the broader conclusion are sort of the goal of these kinds of things. So in the old days, the IAEA looked at the declared facilities and asked, is material removed from those facilities? Now the IAEA is asking a totally different question. They're asking the question, does the overall picture of nuclear activities in this state seem to make sense? For example, are they producing a lot of nuclear material that doesn't seem relevant for the nuclear facilities that they've declared? That would raise a question. Are they importing a bunch of things that other states are reporting to us that they're not telling us about? That would raise an obvious question. Are there facilities that there seem to be mysterious gaps in time in what they were doing, where they appeared not to do anything for a couple of years? That would raise an obvious question. There was one case, for example, of a nuclear research facility that had been publishing a couple journal articles every year for a couple of decades and then suddenly stopped publishing. And it raised the obvious question is, what are they doing now? Is there something secret going on at that facility? As it turned out, the answer was yes. So based on this state level analysis, with all the information they can get from a wide variety of sources, the IAEA then draws what they call the broader conclusion, which is that all nuclear material in the state remains in peaceful activities. So they've drawn that conclusion for 60 states so far. But there is a debate as to whether they really have the information they need to draw that conclusion. They can certainly draw a conclusion that there isn't any evidence to the contrary. But as Don Rumsfeld used to tell us, absence of evidence is not the same as evidence of absence. So there's some debate as to whether they really ought to be so forcefully drawing the conclusion that they really know that all the nuclear material in the state is in peaceful activities. So one key source of information that they use now is open source information. There's lots of different kinds. Commercial satellite photographs, news stories, journal articles, conference papers, trade data. They get now, through the additional protocol, information about imports, exports. They can try to match those up. They also are starting to get information from companies about attempts to buy things that seem suspicious. That sometimes you can get information from social media these days. But now there's this torrent of information, and so figuring out how to integrate all of that information and look for the needles in the haystacks is a difficult task for the IAEA. They also do receive intelligence from member states. They don't, not every member state has intelligence. Not every intelligence agency is willing to share, especially since the IAEA is an international organization, so it has staff from countries all over the world, including staff from countries you might be worried about. Countries are worried about the IAEA's ability to protect secret information, so on. And then some of the member states that don't have big intelligence agencies worry that, maybe there's false information going to the IAEA, especially after the fiasco in 2003 in Iraq, when the United States said, absolutely, there are all these nuclear activities and chemical activities and biological activities that we know where they are, as Don Rumsfeld famously said, and it turned out that it was all incorrect. So what the IAEA does with this information is they use it as pointers, as hints of where to look. They usually don't, however, actually conduct an inspection solely based on intelligence information unless they have some other information that seems to confirm what they're getting from the intelligence information. I'm not going to read this out. This is a quote from Hassan Rouhani, who's now president of Iran, when shortly after he was chief nuclear negotiator, and he basically describes how they had quite a number of activities they meant to keep secret, and the IAEA kept finding out about them from open source. So it's quite an amazing testimony from the point of view of the inspected state as to how effective IAEA open source activities are. Environmental monitoring is another very important new safeguards technique. All nuclear facilities, no matter how well contained, release some atoms of plutonium and uranium, which can in principle be detected. And in particular, if you're inside the building, if you can take a swipe from the wall, swipe from the floor, swipe from the piece of equipment, that will almost always reveal in detail what isotopic mix of uranium or plutonium was processed in that building. Sometimes you can take samples from a kilometer away, pine needles, soil, and so on, and still detect telltale traces of plutonium and highly enriched uranium. Centrifuge plants are harder to find than reprocessing plants. And there's a quote here from the Office of Technology Assessment saying it might be quite difficult to detect a decently designed centrifuge plant. So if you think about how to find a covert centrifuge plant, it's a hard job. These are relatively small, don't use a whole lot of power, so the heat is more or less negligible, not likely to detect that. The electricity supply, maybe you could detect that, but it's quite modest and might even be provided by diesel generators not hooked up to the national grid at all. Size, pretty small, could fit in this building. There are lots of buildings that are big enough. Deliveries of uranium hexafluoride, not likely. You could conceivably deliver all of a year's supply in one truck. Uranium emissions, conceivable, but as I just mentioned, if you have good filters, it's hard to find unless you really know where you want to look, so you can get within a few hundred meters of the facility. You're not likely to find it. One of the Iraqi facilities at Tarmiya had triple HEPA filters to try to make sure nothing got out. Procurement is crucial. So a lot of how we've noticed undeclared activities in countries is by the things they're trying to buy from other countries to supply those activities. But then once you know that they're trying to buy the stuff, you still have to figure out where the place is that they're sending the stuff once they buy it. Some people have talked about, you might be able to hear the spinning, or there might even be an electromagnetic signal from the spinning of the centrifuges, but you can't detect that from very far away. You have to know exactly where to look. So what the IAEA is now doing is trying to integrate the old traditional safeguards and the new safeguards. And the goal is not only to make the system more effective, but also to make it more efficient. So if you have more confidence from the new measures, maybe you can reduce the old measures a little bit. And in fact, in negotiating the additional protocol, the IAEA essentially promised that there wouldn't be a long-term net increase in safeguards expenditure. So that would mean every extra dollar you spent on the new measures, ultimately you'd cut a dollar from the traditional measures. So that does create some concern. Some people worry that we'll cut so much from the traditional measures, we'll end up actually with a weaker system rather than a stronger system. So one example is of sort of expanded safeguards is the safeguards at Isfahan, and then the work to try to figure out what Iran was doing about weapons design. So until fairly recently, the IAEA didn't safeguard conversion plants that took uranium that you had mined and milled and converted it into uranium hexafluoride for enrichment. But if you think about it, having a secret stock of uranium hexafluoride would be the key for having your secret centrifuge enrichment facility. So the IAEA concluded we've got to safeguard Isfahan for that reason, and there's no way we're going to be able to safeguard Isfahan unless we safeguard other countries' conversion plants as well. Because the principle of safeguards is that it ought to be, in general, non-discriminatory. So they've recently started safeguards at conversion facilities, and they do have full safeguards at Isfahan. It's not obvious how soon a substantial amount of UF6 being diverted would really be detected, or whether a covert conversion plant producing UF6 not under safeguards would be detected. Now, in the last decade or so, the IAEA has been looking into what it gently refers to in its reports as the alleged studies. These are a series of activities that appear to have been a program to design a nuclear weapon, and also to test some aspects of that design. Iran, for example, carried out a test involving a hemisphere of explosives with microsecond timing of the detonation at different points to crush a sphere. That is a good description of an implosion nuclear weapon design. Iran argues it was for explosive production of nanodiamonds, and that is something that the Russian nuclear weapons designer who is helping them with that project has been working on. But it's pretty clear that that's technology that's directly applicable to nuclear weapons design. And in fact, the explosive production of nanodiamonds came right out of the Soviet nuclear weapons program, which is where the guy who was helping them came from. He was an implosion systems designer at one of the major Russian nuclear weapons labs. So the MPT is not very explicit as to what's prohibited. It prohibits Iran from manufacturing or otherwise acquiring nuclear weapons. But where in the chain of building and testing a component or designing it starts getting into manufacturing or otherwise acquiring is a hotly debated topic. And traditional safeguards and even the additional protocol really focus on nuclear material. So if you're doing all of these tests and experiments and designs without actually using any uranium or plutonium, in principle, the IAEA has very limited legal authority. But the IAEA has emphasized that it does have a legal obligation to confirm the exclusively peaceful use of Iran's nuclear material. And that in order to confirm that, it needs information about these weaponization activities because they call into question the exclusively peaceful use. So it has not asserted we have the right to inspect for weaponization, but it has asserted we have an obligation to confirm exclusively peaceful use, and in order to, if we were to be able to do that, you would have to tell us what we want to know about this weaponization program. There's been a total deadlock on that for several years. I've been going on for quite a while now, so I'll try to race through some of the rest of this material. So there's some lessons from the Iran case. This is, first of all, these issues are not just safeguards issues. They're issues of high politics and international security. Secondly, if the IAEA gets the right access, the right resources, and the right political backing, it can be highly effective. Hans Blix, when he was head of the IAEA, used to say, I can do my job if you give me access to three things: information, locations, and the Security Council. However, it's clear that a determined state can ignore legal requirements. There have been a series of legally binding Security Council resolutions, and Iran has said, we think those resolutions are illegitimate and we're going to ignore them. As with some of the other cases we've looked at in this class, there are two different nuclear issues with Iran. There's an issue of compliance. Are they complying with or violating their safeguards obligations or their non-proliferation treaty obligations? And there's an issue of capability. Do they have capabilities for enrichment at Natanz or for plutonium production at Arak that raise doubts and would offer a rapid option for building nuclear weapons? Another lesson, I think, is that military strikes would carry huge costs and risks. We'll talk about that more later in the course. And that a diplomatic solution probably is going to require a combination of sanctions and incentives, but it has to address Iran's concerns as well as the West's concerns. And it's going to be difficult to achieve given the level of distrust that exists. So if you ask, are safeguards effective? I would say there's both good news and bad news. On the good news side, in Iraq after 1991, with this extraordinary inspection regime imposed by the United Nations Security Council, the inspections did exactly what we hope international inspections would do. The purpose of inspections is to deter cheating by the risk of timely detection and the fear of what would be the result of detection. And that's the post-2003 US investigation that found no weapons of mass destruction in Iraq, found that that's exactly what had happened. Saddam was deterred because he feared the inspectors would find if he kept the nuclear program going. The picture provided by the IAEA was much more accurate than the picture provided by US intelligence, which was almost entirely false. Iran, similarly, after the illicit activities were revealed, the IAEA has done a very professional job pushing through one cover story after another. North Korea, when the IAEA inspections first began, the North Koreans thought they had cleaned up their reprocessing plant before allowing the inspectors in, but the IAEA took samples that detected that they were lying about when and how often they had conducted reprocessing. But there's bad news as well. In Iraq before 1991, the IAEA didn't detect anything and totally missed a huge nuclear weapons program. In Iran, IAEA really didn't ask the tough questions until it was embarrassed by the revelation of that Iran was building this large enrichment facility at Natanz. And it still has quite a modest ability to find covert activities without being told about them by intelligence agencies. So for finding those kinds of things, the world is still very reliant on intelligence agencies, but there is a useful combination in that intelligence agencies have access to all sorts of resources that the IAEA will never have, but the IAEA has the ability to go and have a legal right to go and check on the ground. And so those each have their role. The other bad news is even at declared facilities, if you have these large bulk facilities, it's very difficult to really confirm that even one significant quantity, only 8 kilograms of plutonium out of maybe 8 tons that are being processed every year, hasn't gone missing. There's a budget issue. The IAEA safeguards budget, as I mentioned, is under 150 million euros a year. A few years ago, it got its first increase in 15 years, despite giant increases in the number of countries with safeguards agreements, the number of facilities under safeguards, the quantities of material under safeguards. I was just updating this talk from just 3 years ago and had to substantially increase those numbers for this talk. The fat has long since been trimmed out of the system. And so they need more resources. There's no doubt in my mind on that. Key states on the Board of Governors have grudgingly gone along with very small increases in recent years, but there's still a ways to go. And this year, even the United States was initially opposing any increase. So let me end with some key issues. An obvious issue is what to do about states that simply refuse to join up to the system or comply with the system. Iraq, pre-2003, North Korea, etc. How to detect the secret hidden facilities, even with the additional protocol in force, still an issue. How to ensure no diversion from the big complex facilities like the reprocessing plant. The inadequate budget and resources. Non-discrimination is still an issue. In principle, in the old days, the inspections went where the material was. And so if a state had complex nuclear activities, it'd have a lot of inspections, and most of the inspection resources went to states like Japan, Germany, and Canada, which most people are not very worried about. With the state-level approach, they're trying to rebalance and focus inspection resources on those countries where there are questions outstanding and where the overall picture doesn't seem to add up. But there's some pushback. You know, is that just a mechanism for being discriminatory and saying we're going to just inspect in countries that we think are suspicious, and then who gets to decide what country is suspicious, and so on. And how to address the political disputes among member states. It's a very political situation in the Board of Governors, often between nuclear weapon states and non-nuclear weapon states, between developing countries and developed countries, between different groupings and different regions. But there are opportunities, and there are opportunities that I think create some really exciting potential career opportunities for people interested in these fields. We need a redoubled global effort on security for nuclear material. We need to provide new fuel cycle supply assurances to convince states that they don't need reprocessing or enrichment plants of their own. We need a fissile cutoff, a treaty that would end production of plutonium and highly enriched uranium for weapons. That might double or even triple the quantity of nuclear inspections worldwide that would be required. We need to work on integrating the traditional and the new safeguards measures. And we need to strengthen safeguards while reducing their cost. And so that really does provide opportunities for a whole new generation of safeguards experts. All right, I'm going to stop there. Thank you for tuning in.